Hello, good afternoon everyone. So today is November 17. Official time for today is 4 p.m. Okay. So today I decided to record lecture for you to reevaluate these topics now, and at the same time you can watch it anytime that you want. Okay, so for today's topic we will going to discuss the second part of data science with R programming. So last time, one of your classmates, Christine Medito Ito, reported the first part for the statistics for data science, again using our platform, R programming. So let's have the second part of that lecture for today. So basically, let's discuss first or recall what's a data science. No? So data science is really essential part of our study as part of information system is concerned or information technology system is concerned. So every one of us is expected to be a data scientist in the near future, and this is one of the in-demand areas of IT and even in computer science. No, pag sinabi nating data science, we need as data scientists, we need to understand the fundamental concepts of statistics. Either we're dealing with descriptive statistics and or in probability theory. So last time dito ito discuss about descriptive type of data analysis, no, yung mga mean, median, mode type of analysis, which also include yung key concept of probability distribution and yung hypothesis, no? So as I recall. So today I'll going to discuss it more on detail, no? So this topic will include the key concept of probability distribution, statistical significance, hypothesis testing, and regression. Again, with the use of R programming. So our learning objectives neither are the following. First, I'm going to discuss what's hypothesis test, as well as to explain parametric test and its type. Together, we will going to explain also the difference between that parametric and non-parametric test and its type. And we need to perform hypothesis tests on different areas such as population means, population variance, and on the population proportion. So on this part, we're going to differentiate rin kung paano natin i-apply hypothesis testing dun sa different areas. Or first, we're going to analyze if it is applicable under population means or population variance ba or in proportions. Okay? So let's start on the first part, hypothesis test. So in hypothesis testing, so when we define hypothesis testing, it is a statistical or testable on the basis of observed data model. No, as we're going to realize values which will take a collection of random variables. So para mas maging clear, let's going to define this test as a formal procedure in the statistics used to test whether a hypothesis can be acceptable or not, or accepted or not. Just like for example, guys, di ba lagi natin narinig sa news yung Okta research result, no, na let's say they are predicting number of cases for the succeeding weeks or months or days based on the current sampling. So somehow they are using hypothesis testing. And then once they occur the result dun sa tinest nila, kaya ang hypothesis parang sa science, diba, is a wild guess. Once they have the result and look if their hypothesis what do you call this, values that they have driven previously is almost close doon sa real time output or result, that's the time that it is accepted. Okay? And if not, kung medyo malayo, then i-calibrate nila into a specific unit para mas mag-model do sa mga susunod na prediction na mas close to reality. Okay? So this is used to infer the results of hypothesis performed on a sample data to a large population. Okay? So the testing methodology will depends on the data used and the reason for the analysis. So these are the different types of hypothesis tests. So we have the simple hypothesis test, complex hypothesis test, null, alternative, statistical. Okay? then they can categorize under the parametric or non-parametric, which we're going to discuss in the succeeding slides. Okay. So again, this lesson will focus on discussing parametric and non-parametric tests. Okay. So let's discuss with parametric tests. So a parametrical statistical test is one that makes assumptions about parameters. So it makes, again, take note of the root word assumption. Okay. The parameters will include defining properties of the population distribution from which one data is drawn. So particularly in this test, inferences are based on the assumptions made about the nature of population distribution. So the tests are used for normal data. Okay? So to simplify, the parametric statistics is a branch of statistics which will assume that sample data came from a population will be adequately enough or modeled by a probability distribution which has a fixed set of parameters. So in principle, the parametric methods will assume that data are normally distributed. Okay? So using the different types of tests, either z-test and t-test and analysis of variance, or the ANOVA test in high statistics, we can normally collect the data or represents one of the mathematical tractable frequency distribution which are closely related to the normal distribution. So to differentiate, z-test and t-test are used if there are two population means or proportions compared and tested, while the ANOVA is used for equality of several population means is tested. Okay? Actually, maraming method no ng parametric test, pero ito yung pinaka most used, yung z-test, t-test, and ANOVA test, or the analysis of variance. Okay? So, and at the same time, in our programming, most of the data scientists will just focus on these two types of parametric tests. Okay? So, let's have an example on how we're going to apply the z-test muna. Okay, so for the z-test, parameter test, z-test is performed in cases where the test statistics is represented as t. Okay, and then the omega is known as the population, which is normal, and the sample size is at least 30. Sample size means the sample value, or this 30 value, will represent the entire population. So, hindi naman kasi pwede sa statistics na kuhanin mo lahat ng entire population or gamitin mo siyang respondent. Okay? So, the formula to calculate Z or the standard in the standard statistics is as follow. Z is equals to X bar minus mu, okay, over omega divided by the square root of n, wherein each of these parameters are represented are as follows. N is the sample size, again, which is at least 30. X bar is the sample mean average from a sample of the x1 to the xn value. Okay? And then mu is the population mean, while the omega is the standard deviation. So, given the consideration that all of the parameter will be given. Okay? Then, let's have an example, problem statement, and then let's try to use that in R. So, let's say problem is given. The test score of an entrance exam fit a normal distribution with a mean test score of 72 and a standard deviation of 15.2. Now, compute the percentage of students scoring 84 or more. So, as we analyze, if we're going to use the p-norm distribution function in R to find the required percentage of students in the upper tail of the normal distribution, since the given score criteria is 84 or more, so we have to evaluate the p-norm, or the probability of normal distribution, which can be used using the following command. So p-norm 84, which is our mean sample, and then yung 72 natin given kanina na mean test score, and then the 15.2, which is the lower standard deviation of that given values, okay, or normal distribution. And then we set the lower tail such as false. So if you were going to ask why it's lower tail test to false, okay, in lower tail, if it is true, it is used to find the probability of values no larger than z. Whereas lower that tail is equals to 4 is used to find the probability of value z or larger. So since we're referring or more, so we have to test the larger lower tail. Okay? So, let's try to evaluate this command in our programming. So, I'll just copy it and then paste it for us to get the normal distribution. So, as expected, ang magiging result natin dito is in terms of percentage. Okay? So, if we are going to ed- um, execute yung pinaka syntax natin, itong values na to, again, this is our syntax, and then let's as expected daw, the result is something like this. Let's double check. Okay, so the result is 0.214176, which means in percentage this is 21.49 or almost 21.5%. Okay, so therefore on the given example, okay, so compute the percentage of students. So therefore, 21.5% out of this total number of students scores 84 or more. Okay? Although hindi binigay yun, di ba? Hindi binigay yung total number of students, but binigay yung mean test score ng lahat student. Parang idea daw, ang average na score ng student is 72. And the standard deviation is 15.2 or yung difference nilang ng score na bawat isa. So, on this analysis, it only means that 21.5% of student got the score of 84 or more. Again, the crucial part here is this. No? Kasi ito, fix naman to, p-norm, yung given na ano natin na score, then mean value, and then standard deviation, tapos yung pagset ng lower dot tail conditions. Again, since we're referring to more condition, we use lower dot tail is equals to false. But if we're attaining and the probability value is larger than z, so we have to lower than the given z, so we have to set our lower tail as true. Okay? Then, using the t-test, t-test is performed in cases where the test statistics is t. Omega is unknown and sample standard deviation is known. And the population is normal. So, for the t-test, formula, no, kung sa manual calculations yung kukumputin natin. So, t is equals to x bar minus mu over the value of s divided by square root of n. Okay, wherein yung x bar is the sample mean, mu is our population mean, s is our sample number or standard deviation, I mean, and then n is our sample number. Okay? So, given the example, find out 2.5th and 97.5th percentile. So I hope every one of you is quite familiar with this quantiles, percentiles, deciles. Diba? In statistics, it was discussed as part of the your statistics fundamentals. So this one, in our programming, we want to find out a certain percentile of student distribution, assuming 5 degrees of freedom. So for that, we can use the quantile functions, which is applied to compute percentiles. Okay, QT against the decimal values 0.25 and 0.975, because again, we're referring to the 2.5 percentiles. That's why it's 0.025. If that's 25, so 0.25 yun. Since we're referring with the other part as 97.5 percentiles, we can simply write this as 0.975. So the syntax in our programming for us to calculate this t parametric test is are as followed. Qt, the of c, 0.2, and then these are the parameters. So from 2.5 to 97.5 percentile, and then the degree of freedom is equals to 5. Okay, so this is just a comment. For 5 is the degree of freedom, no? Given naman yung degree of freedom kanina, di ba? Which is 5 degree. Okay? So, let's try to evaluate the result. Let me just clear this. Okay, so the result is from negative 2.570582 to positive 2.570582 as our range. Now, may counting difference lang tayo dito sa most probably scalar quantity. Okay? Inano niya na, in-average na, 5706. So, the degree of freedom actually refers to the number of values in the final calculations of test. Okay? um, statistic that varies freely. So it is calculated using the formula df is equals to n minus 1, wherein n is the number of values in our data sets. Okay? Okay, so before I proceed, para ma-clear lang natin, most probably we are asking, kailan ginagamit ang z-test at kailan ginagamit ang t-test? Actually, I didn't include, but napakasimple lang naman ng analysis. Dito sa parametric test, both of them given ang standard deviation or yung omega, just like what we have on the previous example. But if you're asking, if do you know the standard population deviation, which is I said given, yes. Ang idea, kung ang sample size is above 30, okay, then we should use the parametric test. Again, the sample size is above 30. Okay? So if yes, use the C test. Pag no, use the T test. Pag below 30, let's use the T test. Okay? Let's try to evaluate a while ago. Kanina sa T test, although dito walang binigay na sample size, no, dun sa given natin, but if in case the given is below 30, automatically pag given ng standard deviation, t-test ang gagamitin natin. Okay? And at the same time, kung tawag dito, kung alam natin standard deviation and then the percentile value, then automatically we should apply the t-test, or kung meron tayong mga percentile and quartile values. Okay, so that's the use of the t-test function. Okay, now let's proceed with ANOVA. So ANOVA test is also used for hypothesis test that will compare the average of two or more group. Again, kanina we're just referring to a single group of population. Okay, for example, let's consider the following statement. An environmentalist want to know if the average amount of populations varies in several bodies of water. So we're referring to parametric values or variable instances, varies, yun yung word natin, in several bodies of water. And another situation, a sociologist wants to find out if a person's income varies according to his or her upbringing. So merong changes, no, depende doon sa average natin ng two or more entities. Okay? So that's the use of ANOVA. So ANOVA has two types, either one-way ANOVA or two-way ANOVA. Okay, so to differentiate one-way ANOVA to two-way ANOVA, in a one-way ANOVA, it only involves one factor or independent variable. Whereas there are two-way or when we consider two factors or independent variable, then we can apply a two-way ANOVA. At the same time, in a one-way ANOVA, the one factor or independent variables are analyzed as are more categorical groups. Okay? So in one-way ANOVA, it uses variance to determine if a statistically significant difference exists among several group means or not. So testing could includes the following parameter. Okay? mu1 up to mu k, wherein the mu is the group mean and k is the number of groups. So, katulad kanina, sabi ko nga, di ba, ang ANOVA ginagamit sa pag-varies ng two or more groups. So, therefore, we're expecting to have at least two groups here. So, for the one-way ANOVA, the ratio of the between group variability to the within group variability follows an F distribution when the null hypothesis is true. Okay? So, for the assumptions, this is the type of parametric test that we're going to consider. First, all samples are random and independent. And then second, each population is normal. Third, the factor is a categorical variable. And then as well as the populations have equal standard deviations. And lastly, the result is a numerical variables. So let's have an example. Let's find out if there is a difference in the mean grades among the sororities, assuming mu1, mu2, and mu3 and mu4 are the population means of the sororities. So for us to calculate that on R, so H1 or the not all the means are equal. So for the distribution test, we can use this given parameter. Okay, dfnum is equals to k minus 1, which is given is 4 minus 1. Okay, or for group minus 1 is equals to 3. And then the denominator, num is for the numerator, and then yung denom naman is for the denominator, we can use the formula n minus k, which is the given value. Okay, here it's in this given normal distribution. So let's assume 20 yung higher value niya, minus 4 is equals to 16. Now let's try to calculate the test statistics, okay, of 2.23. No? So let's consider that. Okay. Okay, so in our programming, hindi naman basta-basta pwede lang natin itong input ng mga values na to. We should have a proper data sets, no? So, we will going to discuss data set later on. Then we will apply this one-way and two-way ANOVA, no? Itong mga parameter. Kasi hindi naman yung ma-appreciate itong mga numerator and denominator value without the data set. So, we will have this example as we go along with an actual data set. Okay? Again, take note, without sufficient evidence, you cannot conclude that there is a difference between the mean grades for the sororities. So for the two-way, as well as this, two-way parametric, two-way ANOVA in a parametric test, given an example, a fast food chain wants to test and market 3 of its new menu items to analyze if they are equally popular, considering 18 random restaurants for this study, and 6 of the restaurants to test market for the first menu item, another 6 for the second one, and then the remaining 6 for the last one. So the given table shows the sales figures of the menu items in the 18 restaurants at 0.05 level of significance. Test whether the mean sales volumes for these menus are equal. Okay. Okay, considering the following value of table, the steps in are to calculate this are as follows. First, we have to create a text file named as passport-1text using this given parameter. Later on, we will try that. Okay, so this is using these values, we can load this into what we call as data frame. If you remember, on the first part of our programming, I discussed about data frame. How do we load it and how we can read values in a data frame format. So, yun yung gagawin natin dito. Okay? But we have to consider syempre yung pinaka-address natin. Okay? And then, we have to concatenate the data rows of df1 into a single vector using this following syntax. No? So, this is for the response data. As expected, we should come out with this result. And then, we have to assign new variables for the treatment levels and the number of observations using these following parameters. And then lastly, we have to create a vector of treatment factors corresponding to each element of R in this given step. So we will do everything of this on the final period, no, starting after your midterm exam. We will perform actual analysis using this parametric test. No? So for today, I'll just discuss the fundamentals of this. Okay. And then for the F distributions, for F distribution or the Fisher-Denecor distribution, it is a continuous probability distribution that arises frequently as the null distribution of a test statistics, most notably in the analysis of the variance for the ANOVA. The F ratio will refer to the values derived from two estimates of the variance, which is described as follows. First, the variance between sample S between, which is an estimate of our variance, and the sample means when the sample size are the same and when sizes are different. So the variance is weighted to account for different sample sizes. While the SS within or the variance with samples is an estimate of our variance, average of sample variances, when sizes are different. Okay? Then the variance within sample is weighted. For the two-way ANOVA, again, I already explained the difference between one-way and two-way ANOVA. It is refers to a hypothesis test for the classifications of data is based on two independent variables. Example, a company bases its sales classification by identifying the sales by a salesman in the sales region. So, for the assumption as well, This two-way ANOVA is used on the given settings. First, the normal distribution of the population sample is given. Then measurement of dependent variable at the continuous level. Categorical independent groups that have the same size. Independence of observations and homogeneity of the variance of the populations. For the non-parametric test, a non-parametric test, or sometimes called a distribution-free test, does not assume anything about the underlying distribution. It is used when the data is not distributed normally. Okay? This refers to a null category since virtually all statistical tests assumes one thing or another about the properties of the source populations. For the non-parametric test, it also have two types. Either we're using Kruskal-Willis test, which is alternative to the one-way ANOVA, okay, in a parametric test. And then for the alternative for our two sample t-test, say test and t-test, we can use the Mann-Whitney test. Okay? And then alternative for the two-way ANOVA, we can use the chi-square test. So chi-square test is the most commonly used non-parametric test. Okay, and then this topic will just limit to the scope using the chi-square test. Okay, so chi-square test is a non-parametric test used to compare two or more variables for randomly selected data. So the features of a chi-square test are as follows. So if we evaluate the frequencies observed in different categorical vary or categories vary significantly from the frequencies expected under a specified set of assumptions. If we consider the square of a normal variate as well as to determine how well an assumed distribution fits on the data. We can also use this as contingency table in terms of market researches. This table are called crosstabs, and as well as it supports nominal level measurements. So good thing about chi-square, this test is good for goodness of fit, and then this test is used for independence of two variables. So the formula for the manual formula of chi-square test in statistics. So this is used to observe the closeness of a sample that matches the population. So the chi-square test statistics, which is represented in x squared, can be calculated as follows. So the equation of chi squared is equal to the summation of our O sub I minus E sub I squared over E sub I within our degree freedoms of k minus 1. Wherein O sub I is the observed count, and then as well as the k is the categories, and E sub I is the expected counts. So goodness of fit test is used to identify the relation between the two attributes as in the case below. First, creditworthiness of borrowers based on their age groups and personal loans. Second, relation between the performance of salesmen and training received. Third, return on a single stock and on stock of a sector like pharmaceutical or banking. And then category of viewers and impact of a TV campaign. So especially right now, most of the politicians are now like they thinking that their prediction that they win. So basically, it is much better for them to analyze or evaluate a given non-parametric test on their campaign or in their run. Okay, so the towards they will not mostly cost at all if they seen that the results of that test would not be based or biased with them. Okay, so the chi-square test for independent of two variable can be calculated using the same formula. But the difference is the degrees of freedom, no, which can be calculated as r minus 1 and multiplied by c minus 1. Okay? For the use case scenario, test of independence is used suitable for the following situation. If there is one categorical variable, or if there are two categorical variables, and you will need to determine the relation between them. As well as there are cross tabulations and the relation between categorical variables needs to be found. Okay, so there are also non-quantifiable variables. For the example, answer to questions like, do employees in different age group choose different types of health plans? So for the given our programming test, again, we're going to evaluate everything of this on the final period, no, as well as for us to be familiarized first with creating data sets. So let's just give this analysis as our problem statement. the manager of a restaurant wants to find the relation between customer satisfaction and the salaries of the people waiting tables. So, condition is, she will take a random sample of 100 customers asking if the service was excellent, good, or poor. Diba? Ngayon, usually we just ask feedback through, let's say, Facebook, no? Kung sa mga page, nandun nakalagay ng feedback. But that is not efficient or statistically accepted. So, normally, you should have actual feedback from the customers. So, with this, she take a survey, no? Or she wants to find the relation between the customer satisfactions and the salaries of the people waiting tables. So she need to consider the salaries of the people waiting as low, medium, and high. No, so her findings are shown on the following table. So it's either testing for the service as excellent, good, and poor, and then yung mga sumasagot, they just set what's their salary level, low, medium, high. No, so most probably the owner would think that the satisfactory will also based on their salary needs, no. Normally pag maliit yung salary, syempre ang mga in-order niyan is yung mga low type o low cost food, na which is normally mas madaling ano, no, magawa, no, or kasi nga yun nga, kaya cost will depend on the production time, no, of a given food in even restaurant. So proportional sila, no, sa bawat isa, yung presyo saka yung way or yung time to pag-deliver. Normally, pag mahal ang orders or food, dumadaan sa maraming proseso, kaya yan is nagre-require ng high amount of expenses or salary on the customer part. So this is the solution in terms of in our programming. So it will come out from the different stages. Actually, it's quite complicated, no? Especially in manual computation. So that's why our programming is very very useful in terms of this data statistics or analysis is concerned. So we can just evaluate that based on these given parameters. Okay, and then after that we can even have the result of it is like acceptable or not in terms of their parameters. Okay, the service quality is dependent on the salaries of the people. Ayun yung naging conclusion, no, based on the calculations on the R. It is depend on the salaries of the people waiting, so as expected naman. So, for the G-square test for independent of two variables, to perform this test in R, we have to consider a table that has a results of a survey conducted among students about their smoking habits. This table, example, has the following: smoke variable, which record the smoking habit of students. Then the allowable values is heavy, regal, ocas for occasionally, and number. Parang low, medium, high, and extreme, no, values. Okay? And then for the variable which record the exercise levels of smoking, so allowed frequencies, frequency, some, and none, no. Ito yung number ng smoker naman, no. Ito yung range or yung heavy yung ano nila, no, yung volume of smoking individually, and then this one is for the variance of smokers, no. So assuming 0.05 as the significance level, we have to test the hypothesis whether the smoking habits or students are independent of their exercise levels or not. So in our application, first we have to build the contingency table using the following sequence, no. So we can use a functions, no. Ang kaganda, may mga functions na sa R, no, for this contingency table, and then we have to find the value of P or the probability using that function. So the output can be saved into our table, no, using that parameters. Okay. So as the result here, as P is greater than the significance level, H0 is not rejected, which means the smoking habits of students are independent of their exercise levels, no? Regardless kung nag-exercise sila or hindi, yung pag-smoke ng bawat isa sa kanila hindi nakadepende doon, no, sa ano nila, no, sa frequent activities what they are doing. Either nag-exercise man o hindi, nag-smoke pa rin sila. Yun yung ibig sabihin na given na problem na yan. Okay? So hypothesis test around mean, variance, and proportions, I mean. Both parametric and non-parametric hypothesis tests are used to check whether the mean, variance, and proportions of the populations have predetermined values or if the values need to be defined. Okay? So as we discussed that in details, hypothesis tests about population means involve testing the hypothesis that compares the population mean of interest with a specified value. X sub 1, X sub 2, and X sub 3 as our assumption is a sample of size n from a normal population, which means mu and variance of 0 to the mean x is distributed normally with the mean and the variance given. So if n is large, x will be calculated similarly, even if the sample is from a non-formal populations. Therefore, for large samples, the standard normal variables corresponding to x bar is z, as calculated in our z-test. So, when population variance is known, we can consider a large number of size n with a sample mean which is represented as x bar. If we test the hypothesis that the sample mean x has been drawn from the population with the mean mu and a specified value mu sub 0, that is h sub 0, h sub 1 values under the null hypothesis, we follow the standard normal distribution approximately. Again, take note that when population variance is unknown, say test is used. Okay. So for the hypothesis test about population variance, hypothesis test about population variance involves finding the squared deviation of a random variable from its means. It will measure how far a set of random numbers are spread out from their average values. So for the formula, we need to consider the case where the data consists of a simple random sample drawn from a normally distributed population. The test statistic for testing hypothesis about single population variance is calculated such as follow. Okay? So these are the parameters for the t-squared test. So ginamitan din ng variance sa kanang probability normal distributions. Okay? And then lastly, for the hypothesis test about population proportion, hypothesis tests about population proportion naman are defined as the ratio of the values in a subset S to the values in a set R. So, for the formula, we can consider a random sample of the size n and the proportions of members with a certain attributes p. So, we need to test the hypothesis that the proportion p in the population has a specified value p sub 0. That is, given that parameter, if p is equal to p sub 0, if p is not equal to p sub 0, if p is greater than 0, and then if p is less than 0. Okay? So for a larger number sample z, we have to consider under different instances or scenario. So as we summarize this topic for the key takeaways, hypothesis test is a normal procedure in the statistics used to test whether a hypothesis can be accepted or not. And then as well as we differentiate z-test from t-test performed in cases where the test statistics is either known or unknown, as well as the degree of freedom, which is the number of independent varieties that makes up the statistics, the use of chi-square test, ANOVA test for such hypothesis test, which can compare the average of between our two or more groups, and then the difference between the parametric and non-parametric tests of the population, which have a predetermined value or the values needed to be defined. Okay? So thank you for listening for today's class. Again, for the applications of our programming given on the previous slides, we will going to discuss that more on detail in the datasets distribution or creating this datasets. Okay? So that's all for now. Thank you and have a nice day.